My name is Dave Solhaug. I'm on the education and training team of Digital's Unix-based software and systems marketing group based in Maynard, Massachusetts. The tape you're going to see consists of two customer presentations. These presentations are Unix, Don't Get Lost in the Jungle, and Delivering Open Systems and Multi-Vendor Integration. These are presentations which you may have seen at the Intruder training. Part of the feedback we got from you at the Intruder training was that in addition to the scripts and slides for these presentations, to help you prepare for delivering it to your customers, you'd also like to see how it might fit in a sales call on video. So with that suggestion in mind, we've put together this tape which will deliver the two presentations, each in their own separate sales call. In this example, I'll portray the sales rep calling on a small manufacturing company. I've been invited in to deliver these presentations by the operations manager of an IS organization, and I'll be delivering the presentations to the IS manager and their staff. Hope you enjoy the tapes. Hope it helps you prepare to intrude. Thanks very much. Scott, thanks again for allowing me this opportunity to speak not only to you, but to your staff. As I mentioned to you on the phone yesterday, what I would like to do in this presentation is to deliver to you a session on Digital's approach to Unix. But not only talk about Unix at Digital, but more importantly, help clarify the Unix marketplace. As we've all seen and as you've experienced in your own business, the Unix marketplace is confusing today. The presentation is actually a unique approach to this, as I think you'll see from the slides. The presentation itself is called Unix, Don't Get Lost in the Jungle. Now, I've heard from you in our discussions some of your frustrations around the competing claims and perhaps conflicting information around what Unix really provides as benefits to you as users. This presentation will take perhaps a light approach to clarifying the Unix marketplace and then delineating for you the digital messages regarding Unix today. Now, we'll cover three areas in this presentation. First, the promise of Unix. What was intended, what was the original vision when Unix was presented to the marketplace? We'll contrast that with the reality of Unix and the frustrations or some of the realities that you're dealing with today. And then finally, I'll present to you Digital's strategy for Unix. How does that sound? Okay, good. Well, let's begin then. So, the promise of Unix. Well, as this slide depicts, the promise of Unix was applications portability. Now, applications portability is important not only to you, but to all of our customers, because what it implies is vendor independence. You've told us over the years that it is important for you to have choices as you develop an infrastructure in your organization to meet your business problems and business needs. Applications portability then means that you write the application once, and then, if needs should arise, move that application without change or with very little change to any other platform. Now, that's something that you've all expressed an interest in, clearly. And that was the promise of Unix. Its economic benefits are clear. From a developer's standpoint, they write the application once and support that across multiple platforms. For the end users of applications, they are comfortable in the knowledge that this application could be moved to another platform if advances in technology or business needs demanded. Now, how does this promise compare with the reality? Well, I think some of your own frustrations bear out the reality that we see here. The reality of Unix is that there is no one standard operating system. As you can see by this slide, in fact, there are many different versions of Unix, each with its own peculiar variations, which limit the potential for choice. Here's an example. Several years ago, the Aberdeen Group conducted a study, and they estimated that there were over 225 different versions of Unix on the marketplace. That is a jungle. And that is part of the reason that there is so much confusion in the marketplace today. What I'd like to do is offer a brief history of the development and evolution of the Unix environment so that you begin to understand how we arrived at the place we are today when we talk about this Unix jungle. It all began in 1969. Unix, as many of you already know, was developed at Bell Laboratories. Ken Thompson and Dennis Ritchie were the individuals responsible for developing this operating system. That operating system, as you may not know, was originally developed on a digital PDP-7. So right off the bat, you can see that digital has been with Unix literally from day one. Now, in succeeding years, the Unix operating system was enhanced and versions were updated to support other digital systems. For example, the PDP-20s, the PDP-1145s, and the PDP-1170s. So we have grown with that evolution, if you will. Now, when we introduced the VAX system, Bell Labs decided that it was time to take advantage of the unique architecture of that system. They introduced version 7 of Unix at that time, or 32V. And this was the version of Unix that was intended to begin to leverage the power of the 32-bit architecture. Now, this also, as you can see on the slide, is a point where a divergence begins. Now, one of the first institutions to receive this was Berkeley, University of California at Berkeley. So if you look at the top of the slide, at BSD, you see one of the first major variants of the Unix operating system. And it's here in 1970 that the Berkeley Unix, 1978, that the Berkeley Unix was made available. Now the Berkeley Unix enhanced that Unix provided by AT&T. They provided additional capabilities such as demand paged memory. They added networking support through TCP/IP. And it was here that there became a choice. Now, in concert with that, or in parallel with that, AT&T, Bell Labs, continued with their updating and progress of this Unix operating system. System 3 was introduced in 1983, and AT&T was committed to enhancing that and continuing the evolution of that product to preserve compatibility of applications and the code. Now, within the slide, you see a variety of derivatives. These are the other companies that have taken the basis of Unix from either the Berkeley or the Bell Labs and have adapted it to suit their own particular architecture. So what we have, and by the way, sometimes we refer to this as the spaghetti chart. It really is quite a mess. But you can see that there is, in fact, quite a confusion and relationship between many of these different versions of Unix. The point of this history and the purpose of this slide is to emphasize for you that there is no one standard Unix. And without that, you as users do not truly have the freedom of choice, do not truly have the vendor independence that Unix originally promised. Not yet anyway. Notice that there's a cautionary note on the right-hand side of the slide. A potential to re-merge all of these different versions of Unix. How's that going to happen? Well, suffice to say we're not there yet. In fact, if you look at it today, you purchase Unix from essentially two camps. Either Unix International or OSF, the Open Software Foundation. Now, what I'll do here is provide you with additional background regarding these two organizations so you can understand the primary differences or the fundamental differences between these two Unix proponents. In the case of Unix International, what you have is essentially an advisory group. It's a consortium of users of the AT&T System 5 operating system. Now, they are not a standards body. They are, however, interested in promoting the use of System 5 as the standard Unix in the marketplace. Now, on the face of it, that seems a noble enough gesture. But what you also have to recall is who are the leaders of this organization. UI, or Unix International, is essentially driven by two companies, Sun Microsystems and AT&T. Think back. It was around September 1987. AT&T actually purchased a 20% interest in Sun Microsystems. Subsequent to that, AT&T and Sun Microsystems announced that cooperatively they would develop the future Unix, and they would develop that standard based on System 5 and optimize that standard to perform on Sun's Spark architecture. Once again, other industries, or I should say other businesses in the marketplace, other computer vendors, said, we like the idea. It is important to establish a standard for our users. Let us participate. We'd like to join in. What do you think the response was? In fact, the response was, no, you can't join our party. This immediately creates a vision of proprietary or closed. Is that really open? To have two organizations controlling the future of this operating environment. What those people were saying is that they wanted control. And the implication for other vendors in the marketplace was that there could be a 12 to 18-month lag time between the release of a product from Unix International and the integration of that Unix into other products in the industry. Now, a response to that specific statement was the creation of the OSF, the Open Software Foundation. I should point out that the Open Software Foundation was founded by Digital. In fact, the early meetings that gathered the other interested parties, the other interested members of the computer industry to meet, took place at a Digital facility in Palo Alto at 100 Hamilton Avenue. They were informally known as the Hamilton Group. And as the discussions evolved, the basis of that became the Open Software Foundation. The Open Software Foundation is based in Cambridge, Mass. Now, the Open Software Foundation is intended to provide both an open process for the arrival of standards, for arriving at standards to be used by your company, and a fair and equitable means of distributing the results of this technical R&D effort to the members of the Open Software Foundation. Today, there are over 150 members of OSF, including Digital, IBM, Hewlett-Packard, and others. Now, there are some important distinctions between UI and OSF that I'll point out here. UI, or Unix International, focuses on an operating system kernel that is owned and controlled by one company. That's Unix System 5 Release 4, which is still under the control of AT&T. They have exclusive rights to that. The alternative, OSF, provides the marketplace with a Unix which is the combination of the best technology on the marketplace. That technology is achieved through an open process known as RFT, or Request for Technology. And it is this process that provides an equitable and fair means of making that technology available to you, the users. So you make the choice. You can work with a company that focuses on one operating system controlled by one company, or you can work with an organization that provides a standards-oriented operating environment, not just the kernel, but environment, based on an open process.
Dave, we've been reading a lot about USL and their announced intention to support ACE. How is that going to affect this?
Good question. In fact, just last week, the Unix Systems Laboratory did announce their intention to join the ACE initiative, which you've heard about in another presentation. And by doing so, what they have done is to take a step which begins to bring together the OSF-based world and the Unix System 5 world. Essentially, what they have agreed to do is to support the Applications Programming Interfaces, or APIs, upon which ACE is built. That is the OSF portion of ACE. That means that in the future, System 5, as delivered by Unix Systems Laboratory, will support the Applications Environment Specification for OSF, DCE, or the Distributed Computing Environment, and DME, the Distributed Management Environment. The implications for the user community is profound. What this means is the potential to preserve the choice that, in fact, was the original promise of Unix.
So does that mean that Unix applications that we develop on an ACE-compliant platform would then be compatible with System 5?
Absolutely. Okay. Any other questions?
Will they also support Motif?
Yes. Thank you. So let's continue. We've talked about the promise of Unix, the promise of applications portability and vendor independence as a result of that, and we've contrasted that with the reality of Unix. Today there is no one standard Unix, although, as we've just discussed, we are taking a step closer with this recent announcement from Unix Systems Laboratory. Let's take a look now. If Unix did not deliver on its original promise, if it did not deliver a single standard operating system, what then has it done for the marketplace? How have we benefited? Well, perhaps more than anything else in the market today, Unix has served as a catalyst for open systems. And it's this move towards open systems that brings us to the environment that you as an organization can best leverage to meet your own needs and to preserve the choice that you originally hoped for. So what we're going to do now is take a look at digital strategy. How does Unix fit in the digital computing strategy? This diagram simply illustrates the basic components of our Unix strategy. The foundation is standards. And this should come as no surprise because standards have been important to digital for many years. And we have been not only a participant in the creation of standards, but many times a leader in forging those standards in the industry. Now there are 5 pillars that are key to our Unix strategy: consortia and initiatives, applications, leadership platforms, quality service and support, and finally, network application support. So what we'll do in the next few minutes is to outline for you what is meant by each of these components of the digital strategy. First, standards. Now, without doubt, digital has one of the strongest standards messages in the computer industry today. Now, evidence of that is on this slide, beginning with the standards that digital has driven in the marketplace. This means that we not only participated in the formation of such standards as Ethernet, POSIX, or X, but in fact we took a leadership position in bringing those standards to fruition. In fact, we like to say that many of these standards exist because of digital, not in spite of digital. Now, we also incorporate many of the de facto standards which are in wide use in the marketplace today. Things such as NFS, the Network File System from Sun, the System 5 interface definition from AT&T, MS-DOS from Microsoft, and so forth. These are de facto standards which are also embraced in our products and our approach to a standards-based open applications environment. But we don't stop there. We also integrate international standards which have been recognized by standards bodies around the world. Things such as ANSI languages, communication standards such as X.400 and more. So when you consider Unix at Digital, understand that the foundation of everything we're talking about is standards. And it's this standards-based approach which provides you with the flexibility to benefit from future enhancements and advances in technology. Now let's take a look at each of those 5 pillars of the Unix strategy. The first, consortia and initiatives. Now, in addition to many of the standards bodies which we not only participate in but lead, we also take a similar role in initiatives which have come on the marketplace. For example, ACE. We've discussed this previously. ACE is an important initiative that attempts to provide a standard operating system environment for both the Unix world and the DOS world, and a standard for platforms, and that is a standard RISC-based architecture. Now, we have not only participated in this, but as you may know, Digital was, in fact, one of the founding members of the ACE initiative. So we're taking a lead role in driving this standard to provide technologies which you will ultimately benefit from. X is another example of a consortium where we have a key role. The X windowing system, as you may recall, came from the Athena project at MIT. Digital was a key funder of this program, and as a result was the first in the industry to implement X in a windowing system on our systems today. So you can see that we've taken not only a role of embracing these consortia or initiatives, but oftentimes a leadership role in bringing these to the market. Let's move on. Applications is the second pillar of our strategy. Now, first we need to point out that we look at applications as an environment. The application environment assumes that we are concerned with more than just the platform or the operating system kernel, which other companies have chosen to focus on. Rather, we're looking at other elements as well. Languages. How will you interface to those languages? What languages will you choose to create your programs? How will you choose to interface to your users? What common means of displaying information can you provide to simplify that process? What about interaction with the network? How will your applications connect to a network and in turn interoperate with other applications or databases in your organization? Data. How will you access the data that's out there? And finally, documents. What standards will you use to conform to and to access complex documents? Now, it's each of these elements that we believe consists of or provides to you the application environment. And it's this broader view of applications that we believe is more realistic in terms of your attempts to provide a business solution. And I contrast this with those in the industry who would suggest that you only need to focus on an operating system kernel. We're taking a much broader view. Now, I've said many times before that standards really are the foundation of our strategy. So let's take a look at how standards fit into each of these key elements of the hexagon model, as we refer to it. Here you can see the variety of standards upon which Digital bases this applications environment. For languages, you can see that we provide the full complement of ANSI standard languages. For user interface, Digital supports the OSF motif standard. This has been agreed upon by many other companies in the industry today. The networking standard. We support the DCE from OSF, TCP/IP, and DECnet OSI, which will be the first to achieve OSI conformance. Now, in terms of data access, there needs to be some consistent way of accessing information. And for database applications, the SQL, or standard query language, is the way we do that. I'll also point out that SQL happens to be bundled in at no additional charge with our Ultrix operating system. Now, in terms of complex documents or compound documents, there needs to be a consistent way of integrating the different components, the different types of data, be it image, graphic, or text, and then being able to transfer and share that information throughout the organization. Digital uses what it calls the compound document architecture. It's this architecture which allows for that consistent development of documents and then sharing of documents throughout the organization. It's also based on a data format called Digital's Document Interchange Format. And this ensures consistency across the different applications. And finally, platforms. As you can see, Digital does comply with standards at the platform or system level. For example, Ultrix is POSIX compliant, and we are XBG3 branded. And we'll support the SCO Open Desktop environment. So as you can see, all of the major components in your application's environment, as addressed by Digital, are in fact based on standards. Now, if we move on, we're looking not only at applications from a development standpoint, but from your standpoint, you would like to know, what can you run today? You want to be able to actually conduct some work today. So here we have a graphic that depicts the variety of applications that you're running or could potentially run on the Unix environment today. For example, with the Ultrix environment, there are in excess of 2,500 different applications, covering the broad range of development environments, engineering environments, manufacturing, and so forth. SCO is the Santa Cruz operation. This is the environment, or the set of applications, based on a Unix that runs on the Intel platform. And in fact, SCO, as an independent software vendor, is the single largest licenser of Unix today. The PIC environment is one you may be less familiar with, but as you can see, it's no less prevalent. There are, in fact, over 4,000 applications written for the PIC environment. The PIC environment is a database environment that can be layered over either our Ultrix environment or VMS environment. And finally, the Open Applications environment. What we're saying here is that for those of you in the organization who need to or choose to develop your own sets of applications, Digital provides the tools to accomplish that. Tools such as Fuse or Cohesion in the Unix environment. And all of this is integrated through ACE. And ACE, as we've heard, brings together these worlds of the Intel applications and the RISC-based applications into a common platform and operating system environment. So what we've looked at so far this morning are the standards foundation of this strategy, the consortium initiatives which we participate in and lead, and the applications environment that's fundamental to your solutions. Now we'll look at leadership platforms. First, when we talk about leadership platforms, we're talking about software. In this case, the operating system environment. As you can see from this slide, Digital's intention is to deliver a unified Unix to the marketplace. And by that we mean bringing to bear the best of the Unix technologies that we've employed to date. Now, as you can see, this product will be known as ODT, or Open Desktop. You'll likely see it as ACE Open Desktop. First to be available, Release 0 in the beginning of the new calendar year, with a follow-on full release for production environments in the mid-year. Now, this is an important step, both for Digital and for the marketplace, because through this unified environment, we will bring the best of technologies to the desktop all the way to the mainframe. Now, notice Digital added features as a component of Release 1, or the full production release of ODT. What do we mean by digital added features? Well, essentially, it's at this point where digital can differentiate itself from others in the marketplace that may choose to provide the ODT, and we'll differentiate ourselves through system management capabilities, through real-time extensions, or through graphics libraries, all of which you can choose and implement as required by your applications or your business needs.
We have a large investment in Unix today. What does this mean to our current Unix and SEO strategy, and how is that going to affect our current systems?
You'd like to know what the future is for those operating environments. As you can see from this slide, the future for Ultrix is that it will continue to be supported and maintained by Digital Equipment Corporation. Much as we've done in the PDP environment for many years now, the Ultrix environment, the Ultrix operating system, will continue to be supported. In the realm of the SEO, ODT applications, which you may be running on your Intel platforms today, notice that the unified Unix that we're proposing brings together the best of Ultrix and the System 5 capabilities found in the SEO open desktop implementations. So in fact, we are protecting that investment. Yes, Scott?
What's going to happen to the Ultrix applications that I'm running today?
In other words, you have code today, how does it play with the future stream of Unix that we produce? Well, in fact, the applications that you have running on Ultrix today are both source and binary compatible with the OSF-based Unix that will be delivered in the future. So you are perhaps in the best of all possible worlds.
So I should be buying Ultrix today?
Absolutely. If you purchase and do your development on Ultrix today, you'll be in the best position to leverage the benefits of the ACE ODT environment in the future. Okay. So we talk about leadership platforms, the first component being software, the operating environment. Let's also look at hardware, because that's another key component of this. When we talk about leadership platforms, we're talking about Digital's commitment to provide the broadest range of compatible systems, ensuring you the ability to choose the right system and the right capability for the right job. When we talk about balanced performance at Digital, what we're referring to is the ability to deliver the performance and the results that you expect in real-world applications, not just benchmarks. And finally, value-added engineering. That's Digital's commitment to provide you with the greatest capabilities, the best of our knowledge and enhancements to the standards-based operating environments that we have today. So now let's move to the fourth pillar in our Unix strategy. Digital's committed to providing quality service and support for your environments. Now you'll see in this slide 3 capable individuals literally swinging to your aid, providing their own support capabilities. Let's take each one in turn. Education and consulting. Digital can provide not only standard education and consulting, but also customized training for products required in your environment. Systems integration and support services. Digital is best equipped because of our networking strategies and expertise to help you integrate the multi-vendor environments that you're struggling with today. And finally, product services. Let's not forget that Digital is a worldwide organization, and it has the service organizations to support both the hardware and software that your businesses are depending on. Now, finally, the 5th pillar in Digital's Unix strategy, network application support. Now you may notice at the top of the slide the Ultrix server. Here we have someone serving the NAS bar and grill, as we like to refer to it, because it's here that digital can really differentiate itself. What we're talking about here is digital's ability to effectively integrate all of the disparate environments that you're faced with in your business today. For example, the Unix systems, such as the Sun systems that you have in engineering, the DOS machines, and the Intel-based machines that Haywood had referred to in his earlier question, as well as the VMS systems that are used in production today. For networking as well, the capability to connect to the SNA network where you and your division need to communicate with your headquarter offices across the country. Now, network applications is very important, and I'll spend another moment on it because this really differentiates digital from many of the other vendors in the marketplace today. Think back to the original promise of Unix. We talked about portability, didn't we? We talked about the desire to take an application from one machine to another. But if you think that through, you might also realize that perhaps that's more important for the development community. Now, Bruce, I know in your environment, you're not very likely to want to take an application frequently and move it from one machine to another one. It's a headache. In fact, if you take it a step further, what we're really talking about as a need in our computing environments today is interoperability. Now, what do we mean by that? We're talking about the ability to access and share information anywhere on the network. And we're taking it a step further. When we talk about interoperability at Digital, and when we talk about network application support at Digital, fundamentally what we're describing is applications that work together. So at that level, we're trying to provide an environment that ensures consistency and compatibility. And we're trying to protect your investment. Yes, Colette.
Well, I'm concerned. How do I protect the investment that I've made in my Sun systems to date?
You're interested in maintaining and preserving the applications code, for example, and the work that you've done on the Sun platform.
Yes.
Fair question. As you consider the future of Unix in your organization, you have to ask yourself, what direction will you take? As we've described in this presentation, we think Digital is best equipped to lead you out of that jungle, out of that confusion. So to respond to the question of how do we protect that investment in Sun applications, there are really several responses, ultimately depending on the nature of your applications. First, if the code that you've developed yourself conforms to standards which Digital relies on so heavily within our strategy, those applications will in fact be portable as the original promise of Unix had indicated. But also, if you have applications running on Sun systems, which you obtain from independent software vendors, keep in mind that Digital has 2,500 and more applications running on Ultrix today. So there are applications in each of those vertical market areas which can address your needs. Perhaps exactly the same application running on the DeckStation platform. Additionally, network integration. When we talk about network application support, we're talking about the ability to preserve your investment. And it's our unique capability to integrate and not isolate those environments. So in the example of Sun systems, clearly they would be integrated into our environment through capabilities such as NFS on a TCP/IP network. So you should feel confident that the work you've performed today on those environments is protected and preserved as you look towards the future and potential movement to the digital platforms. So this morning we've looked at the Unix strategy and we've looked at the marketplace. We've tried to take a little bit of a lighthearted view by referring to this marketplace as a jungle. This morning we've talked about the promise. Unix as an environment, Unix as an operating system, promised applications portability. It didn't deliver. The reality is there is no one standard environment today. But we've seen through this description of Digital's Unix strategy that Digital is prepared to lead you out of this jungle And I hope that through this discussion and future meetings that you'll agree that digital can lead you out of the Unix jungle. Thanks again for your attention. And Scott, look forward to working with you this afternoon. Thank you. Scott, thanks again for inviting me this afternoon to talk to you and your staff about another important topic, one that is frequently in the press today, open systems. We're hearing an awful lot about open systems, and this presentation is designed to help give you a perspective of how digital views open systems and ultimately what open systems and that approach to computing might do for your business. How does that sound with you? Okay, great. Let's begin. We're talking about delivering open systems and multi-vendor integration. To start, we'll discuss why even approach open systems. Why are they important to us as vendors? Why are they important to you as users of the computer systems? Then we'll try to define open systems. And then finally, we'll give you the digital perspective on open systems and how they can benefit your organization. So first, let's talk about why even discuss open systems. As you can see here, we're suggesting that the marketplace has gone through an evolution. In the 70s, in the early 70s, and perhaps before, the marketplace was largely driven by vendors. That is, we provided the systems and the technology, and it was the user community that would do its best to adapt to and utilize that technology. But in the succeeding years, we've seen that users, customers such as yourself, have learned from those experiences, and you have become more sophisticated and, let's face it, in many cases more demanding as users. So there's a shift now. As we look at computing in the 90s and into the future, what we're talking about now is a customer-driven market, more so than in the past. Now there is this assessment that what you are driving towards and what you require really are investment protection, the ability to adapt to change, and ultimately to improve your own organization's competitiveness. Now there are a number of factors that can impact your success in those areas. Things like multi-vendor integration. You have large investments today, you need to protect those. You want to assure yourself of the functionality that is needed for any given application. You don't want to have to trade that off. We've talked before in earlier meetings about the desirability of vendor independence, the ability to install applications on a system, understanding that in the future you may have the ability to move that to another environment if it suits your needs. So there are a number of factors coming into play here. But ultimately, if you ask, why should we talk about open systems? Well, it wasn't the vendor's idea. And I'm sure you can appreciate that. No, in fact, it really was driven by you, the customer environment. Now, this next series of charts is an attempt to help show that the computing for the 90s and this open systems approach to computing really is an evolution of styles. What we're going to look at is referred to as the theory of generalization, and it was developed by an industry analyst, Mark Schulman, who works for UBS Securities. What we're doing is taking a look at different points in time in our computing history and comparing several areas. The vendors involved, how many machines involved, how many operating systems required to support those environments. So if we begin at the dawn of the computing age in the 1950s, we were dealing with an environment where the few computing vendors that were in the market at the time were delivering systems that were incompatible from one machine to the next. So from a customer perspective, if you locked into one vendor, that was your only choice, that one vendor. The machine that you had to choose was that one machine. And the operating environment, that one operating environment. And in those days, as new machines were introduced, unfortunately, They oftentimes were incompatible, so you were still faced with the same constraints. But we move forward now. The rules of the game were essentially changed by IBM in the 60s. In 1964, IBM introduced the 360 series. Now, why did that change the rules of the game? Very important reason. Notice that now we have multiple systems available. One operating system, multiple hardware environments from one vendor, providing you, the user community, with an upgrade path and preserving your investments on that platform. Now, that served as the paradigm for computing for over 20 years. And you might be surprised to learn that the most successful implementation of that model was actually the VAX architecture from Digital Equipment Corporation. Now, you're using VAX today, and you have been using VAXs in your organization for some time, so you're familiar with the evolution of the VAX computing architecture and the benefits that it brought. More than any other vendor in the industry, Digital proved that the discipline and adherence to an architectural specification could provide benefits for the user community and for Digital itself. We grew to be a $13 billion corporation. So here you see one vendor, Digital, providing a range of systems or machines that were compatible, all of which running on one operating system. But once again, times change, and that's what this diagram is indicating, because the next step in the evolution is the popularity or the growing popularity of the Unix operating environment. Here we see, really in the late 80s, mid to late 80s, an increased interest on the part of the user community on the Unix operating environment and the promise of Unix. Remember from our earlier discussions that the promise of Unix was true applications portability. So what that means for our diagram here, multiple vendors providing systems, a variety of hardware systems, would all run the Unix operating system, giving you, the user community, the ability to pick and choose those systems best suited for a specific need. Sounds great. But as we've learned in other discussions, that's not quite what happened because there is no one standard Unix. Consequently, you really don't have that level of choice. But nonetheless, the move towards open systems is clear, and Unix, more than anything else, fostered that movement. So now we talk about computing in the 90s, and we're talking about open systems. Here, we're making the distinction in the realm of the operating systems. We believe that open systems is not tied necessarily to one variant of an operating system. Rather, it gives you the flexibility to utilize the systems in the market best suited to your needs. So you can see in the diagram then that we're proposing, through open systems computing, a marketplace where you, the user, can choose from a variety of vendors, a variety of machines that may potentially be running a variety of operating systems, and yet maintaining the compatibility and interoperability that's required to run your business efficiently. So this is where we've come from. And this is where we're headed in terms of open systems computing. So, to summarize the forces that are really coming to bear on this marketplace, you have a number of vendors, the desire to choose from a number of vendors' machines and multiple operating systems while preserving your previous investment, maintaining that ability to adapt to change in your needs or change in the competitive environment, and to increase your own organization's competitiveness, to keep up, to keep pace. So we've talked a little bit about why this discussion of open systems. Let's talk a little bit about the factors that you will achieve, the benefits you will achieve. Fundamentally, as I've said, users are asking for it. That's why companies such as Digital Equipment Corporation are talking about them and delivering them. Open systems will provide portability ultimately, but more importantly, vendor independence, flexibility, multi-vendor integration, lower costs, and the ability to choose the right level of functionality for a specific job. Now, the key to achieving all of these factors is the adherence to standards. And in this case, we'll talk a little bit about how important standards are in digital zone implementation of open systems. Yes?
Dave, vendor independence sounds great. How is digital or any other vendor going to be able to provide an open environment and stay in business?
Fair question. What you're asking is, how can we all propose to provide the users with the freedom to choose anything they want and continue to be viable? Without question, this market has become increasingly competitive. The open systems marketplace is the example of that. In digital's case, we intend to differentiate ourselves in that market in several ways. We'll differentiate ourselves through integration, services, and innovation. Integration means leveraging our expertise and abilities at worldwide networking and integration of not only our own environments, but multi-vendor environments. Services refers to our capabilities as a worldwide computing organization to satisfy your needs wherever your company may be, not only for hardware and product support, but also special consulting or educational services above and beyond the norm. And innovation. Digital frequently speaks of value-added engineering as a complement to or enhancement to the standards upon which we build our products. And it's this value-added engineering that provides and creates the innovation and opportunity not only for us, but for our customers to be more competitive. Okay, thank you. So we've talked a little bit about why open systems are important to vendors and to you as users. Now let's define open systems. Now clearly there are as many potential definitions as people who will spend the time to talk to you. Let's try and clear that up and certainly clarify for you digital's definition of open systems. First, let's look at the world of possible definitions. You can see here a range of terms that you're probably very familiar with and things that you've heard in the press, the trade press, and from other vendors. Unix is what open systems is all about, they'll say, or Spark, or how about volume, or how about portable applications, and on and on. Our view is that each of these ultimately are components of open systems, but none of them stand alone as the definition of open systems. And this is an important distinction between our view of open systems and some of our competitors. So let's take a look then at some of the characteristics that digital views as being critical to the development of an open system. A vendor-neutral applications environment that's compliant with international standards. Now we've highlighted here applications environment because this is an important distinction between our view and some of our competitors' view. As you'll see later in the presentation, when we talk about applications environment, we're focusing not just on an operating system kernel, like Unix System 5, rather we're looking at the other key elements that you as a user cannot ignore if you're going to build productive systems. And by that I mean aspects such as languages, user interface, networking, and things of that sort. And notice that we're also suggesting that this be a vendor-neutral process. Again, contrasting ourselves with some competitors, we're suggesting that the foundation for this open system not rely on one vendor's definition of what an open system is. You'll see that in a moment. Now, an open system, for it to be truly open, needs to provide for portability of data and applications. And as we'll describe in a little bit more detail, That means moving applications, if necessary, among machines, but also providing for the ability to access that data from a variety of machines. Now, portability of users is a unique concept. We're pointing out the importance of the resource that you have in your organization, the resource being the people, and the time and the investment made in getting those people trained and up to speed. If you have a consistent user interface, as we'll see, you have a more open system, and you thereby are saving your organization considerable amounts of money in retraining. And then finally, multi-vendor and interoperability. This becomes more important as you try to protect the investments that you've already made in the past. Multi-vendor interoperability, as you'll see, is a key point of differentiation, we believe, at Digital. Another key element of open systems computing environments. And true implementation of open systems must take into account multi-vendor environments. Another way of saying that is we can't overlook the investments that your organization has made prior to this point in time. You have invested heavily in your systems, be it from IBM, Hewlett-Packard, Sun, as well as Digital. Those investments can't be thrown away in favor of something called open systems. So in our definition, we need to embrace and protect the investments that you've made in the past. Also, it's not only the definition of open systems that's important, but also the process by which you would arrive at these standards. Here, we're suggesting, and the IEEE suggests, that this be an unencumbered open process, and in fact maintained by this consensus process. Said another way, we can't allow the definition of open systems to lie in the hands of one organization. Rather, it's the benefit of the input from all major players in the marketplace today. And it's a consensus process that lets the best of that technology come to the surface and make itself available for open systems. Now, if you essentially agree with the points we've discussed up till now, you'll notice that Digital's approach to open systems in fact maps very closely to the IEEE organization. And for those who may not be familiar, the IEEE organization is the one which manages and is responsible for POSIX. And that POSIX effort is a key, as many of us know, in developing a standard operating environment, providing us with the flexibility that we've been searching for. So we've talked a little bit about this aspect or this definition of open systems. Let's take a more graphical approach to illustrate how you, the user, have been driving the needs in various areas for open systems. Now you can see here that the user needs on the left of the slide come in several general categories. Applications and data portability, user portability, and multi-vendor interoperability, as we've described. Now, the point of this slide is to illustrate that once again, the market is driving the need for consistency in each of these areas. And as a result of those efforts, and the efforts of others developing open systems, you can be assured of systems that will behave in a consistent and predictable manner in each of these areas. Now, just to ensure that we're all working with the same definitions of these three categories, let's step briefly through each one, using a graphic to depict each one. First, applications and data portability. Well, when we talk about application portability, this essentially is the original promise of Unix that we talked about earlier. We're simply saying that an application written on machine A to an identified common application programming interface will be compatible with a completely different machine as long as that common API is present in both environments. So, as we've talked about, the ability to move an application from one machine to another with little or no change is the goal here. So that's what we mean by applications portability. Now, user portability is something quite different. I mentioned this earlier. When we talk about user portability, we're talking about protecting the investment that you've made in training your people how to use applications. Here you'll see on the slide we have different machines, System A and System B. And in this example, we're highlighting a common interface, a common user interface that's present on both machines. Adhering to that common user interface will once again make the system easier to use and more familiar to your user community. The analogy that's used by the POSIX committee is ensuring the drivability of an application. Each of us knows how to drive a car. We all know that the accelerator is on the right, the brake is on the left, and regardless of what model we get into, we know how to steer it, how to start it, and how to stop it. And the same can be said then for the intent of a common user interface in this example. So that's another key component of open systems. And then finally, multi-vendor integration or multi-vendor interoperability. This is different than applications portability. We're not suggesting that you need to take the application from one machine and move it to another. Rather, we're saying that you recognize that applications running on one machine are doing just fine where they are. There's no need to change. But there is the need for other systems and other users in your organization to access the information. So when we talk about interoperability, as in this example, a payroll application that might be running on an IBM system that you have here may need access to some key data files sitting on a VAX in human resources. So allowing the applications to work together and allowing you the ability to access that information is what we mean by multi-vendor interoperability. So these are three key elements of open systems and key elements that have been driven by your needs in your organization. So if we were to recap what is an open system, we're talking about an applications environment that is a focus on the broader picture of not just the system or operating system kernel, but all of the other elements that are necessary to build applications. We're proposing that it's vendor neutral, that no one vendor in the industry own the specification to what is open, and that it be based on international standards. The result of this is that it would provide you with portability of data and applications, portability of users, and the ability to interoperate amongst different machines in your environment. So that's what we mean when we talk about open systems. Now let's spend some time on open systems at Digital. This model is frequently referred to as the hexagon model. And we use this as a way of highlighting the benefits and the key differences of looking at open systems from an application environment perspective. First, notice that the application is the center of focus. We're not talking about the importance of one operating system kernel, although that is one component. At Digital, open systems means taking into account how you will interface to the outside world in many domains. For example, languages. Having a standard set of languages that are compatible across a variety of different machines. Having a consistent user interface. Being able to provide the networking. How will your applications connect to other systems? You need some consistent way of handling that. And what about data? How will your applications access data as you build new systems? And complex or compound documents. How are you going to manage the interface of that? At Digital, open systems really means an open applications environment that's built on industry standards. So with this hexagon as the template, let's take a look at the industry standards we're talking about and how those standards come into play. Here we've filled in the hexagon with the key international standards upon which you can build your applications, and as a result of which you can help assure yourself of applications portability. So in the realm of languages, we provide a full complement of ANSI standard languages. For a common user interface, we're providing and support the OSF motif standard. In terms of networking, a variety of alternatives, be it OSI, DECnet, TCP/IP, or the up-and-coming DCE, Distributed Computing Environment. Digital will support each of those. In terms of your interface to data, you have the ability to standardize on SQL, and Digital recognizes this important point by bundling in the SQL in the Ultrix license for the Ultrix operating system at no additional charge, and also available in the VMS-RDB system. And then finally, documents. How will we provide consistency when we try to integrate complex or compound documents? There are a number of standards here that we're working towards. For example, ODA, the Office Document Architecture, or ODIF, Office Document Interchange Format. These are the standards upon which Digital's compound document architecture are based. So this will assure you of applications portability, building on that foundation. Bruce.
You've referred to some of these standards in a future tense. I've got business problems I need to solve right now. Why should I wait for these standards to be developed, and how are they going to help me with the problems I have today?
Here's an example of why the Open Software Foundation might be unique in the marketplace. The OSF brings together, through a consensus process, standards or standard-based solutions that are demanded by the marketplace today. Many view the OSF as an accelerator of standards. How is this accomplished? You may be familiar with the RFT process, the request for technology. It's this process that OSF employs to solicit recommendations from throughout the industry, and then through their own R&D efforts, deliver back to the industry in an equitable form the benefits and the best of that technology. So while there may be concern on having to, quote, wait for standards, you could look to the OSF as an example of one mechanism that is actually accelerating the consensus towards standards-based solutions that you can use in your application today. Now that's all nice talk, but what about examples? For example, the OSF motif user environment announced by the OSF in December of '88 was the first tangible result of that effort. And just weeks ago, the specifications were announced for the DCE. So we have tangible evidence of the standards that are being produced and offered by that process. Okay. All right, so we're talking then about the application environment. Let's move on as we look at Digital's view of open systems. Here we're taking a broader view. We've spoken earlier of the importance of multi-vendor integration. This diagram depicts what I know you've seen before because I've showed it to you. The NAS arrow, the Network Application Support diagram. But it's an important message when talking about open systems. We're illustrating the fact that Digital is unparalleled in its ability to integrate the diverse range of systems and operating environments that you're challenged with today in your own environment. And it's this view of today and computing in the future that we believe differentiates Digital. So let's continue. Now, all of the things that we've said to this point regarding open systems should be desirable. The ability to have a choice, the ability to maintain applications portability and multi-vendor interoperability. Digital's view embraces this. What does the outside world think? Here's an example of a quote from the Gartner Group. They believe that, in fact, there is no other company that's currently implementing as full a range of open system solutions or multi-vendor networking capabilities. So we have independent experts in the field agreeing with the progress that digital's making in that arena. Now, if we talk about interoperability, and we try to then locate all of the NAS services, that is, the network application support products and services, into the hexagon, what we have here is a demonstration of how the applications environment view of the world is actually being implemented by digital. When we talk about network application support, we're reminding the customers of the importance of languages, user interface, networks, data, and documents. And we have products and services to help provide the capabilities you need in each of those areas. So this is another unique way of looking at what we mean by network application support. Now, there are many in the market who would say, Unix is open systems. What we're suggesting is that that's not the case. In fact, our definition of open systems suggests that open systems are not Unix. In fact, the discussion of open systems should not be which operating system, but rather open systems are industry standards. Industry standard interfaces as we've depicted for you in the hexagon model. Now, yes, Colette.
You know, Dave, it strikes me that digital's approach is very different from that of its competitors.
That is true. That observation is true. In fact, we have contrasted ourselves with some of our competitors. The marketplace has also noticed that change. In fact, if you look at this quote from Fortune magazine, you'll notice that they're pointing to digital's approach as unique and no longer requiring a focus on standardization around one operating environment or set of hardware, but rather this move towards industry standard interfaces. So you're insightful in that regard, and the marketplace has seen that as well. Let's see what that means for the solutions that can be delivered. This slide depicts graphically the key and fundamental difference between a standards interface approach versus an approach focusing on standardization. On the left, we have the hexagon that we illustrated earlier, where you have the application at the center, and it's the use of standards-based interfaces around that application that assures you of the flexibility to move to any environment that is best suited. You're not tied to one operating system environment. On the right, we have a graphic that depicts what it looks like if your view of the world of open systems is in fact dependent on an operating system. In this example, if you do define open systems as being dependent on a specific variant of an operating system, then all of your applications become tied to that variation of the operating system. Is that open? We think not. So when you look at the contrast, standardized products, what does that mean? It means choosing one environment and then having to stick with that environment. It requires migrating everything you have to that environment. Whereas an approach that's based on standard interfaces gives you the flexibility to leverage the strength in all of the environments that you have today. Remember, we talked about protecting your investments. Scott, for example, in your environments, there's a large population of PCs, large number of workstations. Bruce, I know that you're certainly interested in maintaining the integrity and future of the IBM environments. We have to protect that in our view of open systems. And that's the digital approach. We believe it expands your choices, really. and ultimately gives you access to technologies as they evolve in this market. So we've talked a little bit about this contrast between open systems from a standard interface point of view versus standardization. Here we're taking a look at how digital actually delivers standards-based solutions in not only the Unix environment, but also in commercial environments such as VMS. What we have here is, once again, the hexagon model. And notice the standards surrounding the application at the core. Whether you choose the Unix environment, digital provides standards leadership in terms of the Ultrix environment, or if you're looking for commercial strength capabilities in your production environment, and you'd like to continue with the VMS approach. Open systems is available to you in either case.
David,
Scott,
won't I be trading performance for compliance to standards?
so you're concerned that somehow there's a trade-off
Yes.
through standards compliance. A couple of points. First, we've spoken at length about the importance of standards interfaces. As these application programming interfaces mature, and they have been for some time, you'll find that the trade-off in performance actually is much less than it may have been years ago. Furthermore, the raw performance of the systems that we're talking about today are much, much greater. So if in fact there might be a 10 or 15% difference in terms of performance as a result of working with a standards-based approach, is that really critical if we're talking about the much higher performance systems available to us today? I think the answer is that we're at a point where that becomes less of an issue. Okay? Now, because standards are such an important part of digital's story, it's important for you to understand how digital perceives itself as a leader in standards. It's one thing to talk about conformance and compliance to standards, but it's quite another thing to drive standards in the industry and to have an impact over the standards that are made available to the industry. This diagram illustrates the process which ultimately digital employs over time in many of the standards that we have delivered to the market. We start at the top, where fundamentally we do comply with standards that are available at a given point in time as we enhance our own environments. The next block to the right talks about creating the richest set of tools based on those standards. What we're talking about here is digital's value-added engineering as a means of creating innovation and ultimately more capability for your applications. But then we can return the benefit of that expertise to the market by resubmitting that to standards bodies. So then that becomes a driving standard in the marketplace. Now let's take a look at an example of how that might come to pass. We'll look at the windowing environment as one example. When digital set about the task of creating a windowed environment that would run across all of its platforms, it worked with the X windowing system. Now, a little bit of history. In the early 80s, the X windowing system was developed out of MIT through a program called Project Athena. Digital was a primary driver and funding organization for that program. Subsequently, Digital was the first vendor in the marketplace to deliver a windowing system based on X for its work systems. And that product was called DEC Windows. We took X and provided a number of enhancements, not only to the look of the product, but to the ability of a programmer to utilize the X windowing environment, the X toolkit, XUI toolkit. The next step then, as you see on the diagram, was to submit that work. We submitted DEC Windows to the Open Software Foundation as a proposed common user interface to be evaluated by OSF. That submission was in July of 1988. And then in December of 1988, we come full circle, and the OSF announced its decision regarding a common user interface. The name that they gave this interface was OSF Motif. The fundamental components of that were the XUI toolkit from Digital Equipment Corporation. The look and feel of the windowing environment came from Hewlett-Packard's New Wave. The real work in terms of X programming is in the toolkit. Some estimate that that could be as much as 80% of what we see in this. That's the added value that digital delivered. And that's what we refer to as one point of evidence as standards leadership. There are other examples as well. For example, digital being the first company to deliver this open set of standards and commercial strength functionality. We're doing that on the VMS operating system, and that's through POSIX compliance and XPG branding. But we don't stop there. We're also the first company to have actually shipped OSF 1. We did that in February of this year. So don't forget that we're not just talking about the importance of open standards, but we are delivering products in that environment.
Now, Dave, I'd expect you to talk about Unix and VMS, but what about all those PCs out there? How do they play into the open systems environment?
An important point, because we've recognized in your organization that there are a lot of personal computers to be integrated into your environment. Well, in fact, network application support is another key element of our standards leadership. And as you can see here, Digital was the first company to design and deliver a set of standards-based products and services with the intent of integrating this diverse environment from the ground up. And it is network application support that will help you integrate the PC environment that you have invested so heavily in today. Another example of open systems leadership and standards leadership. I've said before that Digital not only participates in many of the committees which drive standards, but we oftentimes are responsible for heading up those efforts. These are just a few examples. Digital was a key participant in the development of the Ethernet standard in cooperation with Xerox and Intel. The X window system I've already described for you with regards to Project Athena and our work at DEC Windows. POSIX, a very important committee when you talk about standards and portable operating systems. Not many people know that the chairman of POSIX is Jim Isaac, who works for Digital Equipment Corporation. And OSF. We've spoken before about some of the unique characteristics of the Open Software Foundation as an accelerator of standards. We believe there's a lot of benefit there. Digital founded OSF. Now, we've made a lot of progress, we believe, in this move towards open systems. That's our view. Here is a suggested view from an outsider, Mark Schulman, an industry analyst working with UBS Securities. He has suggested that Digital is providing a broader implementation of open systems, more so than any other vendor. And he also suggests that this isn't necessarily the first time that we've provided this capability in advance of its general recognition elsewhere in the industry. So he's saying that at times we are providing capabilities in advance of the market's recognition of their value. The market's catching up. They're starting to understand. So here we are. We've looked at why open systems are important to you as users. We've looked at open systems and from a definition standpoint, what are they? We've proposed to you Digital's definition of open systems. And then finally, we've demonstrated for you what open systems look like at Digital. We believe all of this constitutes the open advantage that Digital will deliver to your company. Thanks for your attention, and I look forward to working with you in the near future.